Hey everyone, welcome back, and today let's solve Leetcode problem 2206 titled Divide Array into Equal Pairs. So we're given an integer array nums consisting of 2n integers, and we want to divide this input array nums into n pairs. Basically, each pair is going to have two elements, such that each element in every single pair is going to belong into only one pair, meaning we can't have elements be in multiple different pairs, and the elements present in a pair have to be equal. And we want to return true if nums can be divided into n pairs, or false otherwise. So in example 1, we have our input array nums to be 3, 2, 3, 2, 2, 2, and in this case we have an output of true. We can match these two 3's together because they are equal, and we can form them to be one pair. We can match these two 2's as one pair because they are equal, and finally these two pairs as one to be equal. We'd have two pairs of 2's, so that'd be 2, 2, and 2, 2, and we have one pair of 3, 3. That is a total of 2 times 3, or 6 elements, which is also the number of elements that we have in our entirety input array nums, right? So in that case, we have an output of true. In example 2, we have our input array nums to be 1, 2, 3, 4. In this case, we don't even have any equal elements. We can't divide this into two pairs where each element in each pair are equal, and so we have to actually have an output of false. So for the constraints here, we see that the input array nums is always going to have a length of 2n, and so n is always going to be between 1 and 500, which is relatively small in terms of input constraints and runtime complexities, and any value in the input array is not going to exceed a value of 500, which leads us to the main observations that we can really make in this problem. Notice how in example 1, all of the values actually had an even frequency, and to kind of elaborate on that, it always had a frequency that was actually divisible by 2, meaning it had a remainder of 0 with 2, right? Because as long as every value, every unique value that is in the input array nums has a frequency or the number of occurrences that are divisible by 2, we know we can form an even number, or rather not an even number, but a valid whole number of pairs with them, because we know each element, or each pair has two elements, and so as long as every unique element has a frequency that is divisible by 2, we know we can easily break them into pairs without having any elements left over, without having a remainder of 1. And so that's really all we have to check. In this case, 2 had a frequency of 4 and 3 had a frequency of 2. Both 4 and 2, both of those frequencies are divisible by 2 because a pair has two elements. That's why we're checking if it's divisible by 2. And so this is actually going to be a valid input array nums. And that leads us to just checking all the frequencies of all the different unique elements. If all of them are divisible by 2, we can form pairs with all of them, and that means we would actually have a valid input. So a nice way to check for frequencies is using the counter hash map or built-in dictionary in Python. So I'm going to get the counter, I'll just call it count, and it's going to be initialized to the counter of my input array nums, and iterating through each value in the count, or rather in the counter, if the count at I, and count at I is basically the key value pair of the current value I. If its frequency count at index I modded by 2 is not equal to 0, that means it is an odd frequency, and we can't form a whole number of pairs of two elements at a time in each pair with it because it's not divisible by 2, and so we have to return false. However, if that's not the case, if we don't return false for any values, meaning all the values have do actually have frequencies that are divisible or moddable by 2 in the input array count, or rather in the input array nums and in the actual counter count, in that case we can return true if we haven't returned false once the for loop is actually done executing. Sorry, this should be true. So this should actually be accepted unless I made any syntax errors here. And as you can see, this really is just about as efficient as you can get it to be. So for the runtime complexity of this solution, this is actually going to be a linear time big O of n solution, because of course we're really only iterating through each element exactly once, checking for its frequency, at least at most, right? And so this is going to be a big O of n or linear time runtime complexity. And for the memory or space complexity, it's also going to be linear because we're actually using the counter, which is going to have at most n elements, where n is, or rather 2n elements, where n is going to be the length of the input array nums, or rather 2n is going to be the length of the input array nums, n is going to be the number of pairs that we form, and so it is also a linear memory or space complexity. And on a high level rundown, we're simply checking for all the unique elements if they have frequencies that are divisible by 2, because as long as every single value has a frequency divisible by 2, we know that we can form a pair with that specific element to be equal, right? And so we would have to actually have a valid input. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.